Dear students, welcome to our HomeLearns class 11 Mathematics. Today's in this class, we will discuss the questions of miscellaneous exercise of chapter 1. In this class, I will solve for you the questions 1 and 2, and in the coming classes the rest of the questions. Miscellaneous exercise means that these questions are based on the full chapter. The concepts we have studied till now, all of these questions, that is 1, 2, 2 till 16, there are 16 questions in this exercise. And if we solve these 16 questions, that means it is a complete revision of chapter 1. So now this is the opportunity to revise this chapter 1. So keep watching or attending this class one by one. Now let's start. What is the question number 1? Question number 1 states that decide among the following sets. There are sets A, B, C, and D. Which sets are subsets of one and another? Which set are subsets of one and another? How we could calculate? Now, A is such that X is a real number and X satisfies this equation. The equation is like this. Equation is X square minus 8X plus 12 is equal to 0. This is the equation. A set, what A set states, A set is such that x belongs to R and X satisfies X square minus 8X plus 12 is equal to 0. These are the numbers 2, 4, 6, 2, 4, 6, 8, and 6. So how we can write the numbers, elements in set A? X square minus 8 plus 12. If we put X as a 2, then this equation we will solve. X as a 2 means 2 square minus 8 into 2 plus 12, and it becomes 4 minus 16 plus 12, and it is 0. So we can say that one element of the set is 2. Then similarly, if we do it for 4, then 4 square minus 8 into 4 plus 12 is equal to 16 minus 32 plus 12. And the result, what would be the result? Result would be minus 4. So we can't say that 4 is the element of A. 4 is not satisfied. It means if we put X is 4, then the result would be minus 4. Then we can say that 4 is not an element of set A. Now, if we solve this for 6, then 6 square minus 8 into 6 plus 12, it comes out to be 36 minus 48 plus 12. 36 and 12 is 48, and it is 0. We can say that 6. If we satisfy it for 8, 8 8 is 64. 64 minus 64 plus 12. And so on. So this, the equation x satisfy means if there is the value of x is 2 and 6, so that satisfy this equation. So now set A is this, set B is in front of you, element 2 4 6. Set C is also in front of you, 2 4 6 8, and D is 6. As we have studied in the chapter and the related exercises, that a subset, a set is a subset of another set if all of its elements consist in another set. 2 6 2 6 is in B, 2 6 is in C, but here in D6 we can state that A is a subset of B, A is a subset of C, but A is not a subset of D because D has only 6 elements and A has only 2 elements. B is a subset of C. 2 4 6 2 4 6 elements. These elements are in set C. It means C consists all of the elements of B and its own elements 8 and onwards. So we can state that B is a subset of C. C is not a subset of anybody because its all elements are more than other sets. Then D has 6 elements. So D is a subset of A. D is a subset of B. And D is a subset of C. It's all about the exercise. I hope you understand it very well. Now come to the second question. In each of the following, determine whether the statement is true or false. If it is true, then prove it. If it is false, give an example. We have to satisfy. If X belongs to A and A belongs to B, then X belongs to B. If X belongs to A means any element that belongs to A and A belongs to B, A set A's all elements belongs to B, then X means any element of A is the element of B. Okay, let's take an example. Let A is 1 2. B is 4 2 3 let B 1 2 like this. 3, 4. Now, 2 belongs to, or 1 belongs to A, and A belongs to B, because all elements of A is in B, but 1 doesn't belong to B. Why? Because 1 to it is considered as a single element. It is considered as a single element in the set. Hence, 1 doesn't belong to, but fully 1 2 belongs to B. So we can say that it is a false. It is false. A is 1 2, 1 2 3 4. 1 belongs to A. 1 is an element of A, and A fully belongs to B, because 1 2. So we can state here that 1 belongs to A belongs to B, but 1 doesn't belong to B. So this statement is false. This statement is false. A is a subset of B. B belongs to C, then A belongs to C. Let A is equal to 2, B is equal to 1 2, and C is equal to 0 1 2, a single element 1 2 and 3. A is a subset of B. It is true? Yes. A is a subset of B because all elements of B consist in A consist in B. A is the subset of B. But B also belongs to C. B also belongs to C. So B is element. This set belongs to this. So B belongs to C. Both these, then A belongs to C. A's element is 2. But C, there are no 2 elements, because this only one element is 1 2. But C doesn't belongs to 2. So 2 doesn't belong to this. We can state that this statement is also false with the example I have solved for you. This statement is again false. So it is not necessary that if A is a subset of B, B belongs to C, then A belongs to C. It's not necessary. If an element belongs to A and A belongs to B, then also it's not necessary that the element of A may be in one, in another, in B. I hope you understand it very well. Now, A is a subset of B. A is a subset of B, B is a subset of C, then A is a subset of C. Let's consider it with the help of an example. A, if an element of, let X an element belongs to A, it means this X also belongs to B, because of property of A is a subset of B. This symbol is because A is a subset of B. Okay. Now, X belongs to B. It means X belongs to C also, because B is a subset of C. Hence, we can prove that A is a subset of C, because all elements of A, B, C means A's element X, then that element is also in B, then that element is also in C. Then we can say that A is a subset of C. It's true. I hope you understand it very well. And next question, part 4. A is not a subset of B. B is not a subset of C. A is also not a subset of C. Is it is true? Let's take. Let A is a set having element 1, 2. B is a set having element 3, 4. So B is not a subset of C. It means C's element, if C has element 1, 2, 5, 6. C can be the element 1, 2, 5, 6. So A has element 1, 2, and B element 3, 4. It means A is not a subset of B. A is not a subset of B. B has 3, 4. B is also not a subset of C. But A has element 1, 2. B has element 1, 2. So A is a subset of C. We can say that this statement is also false. So it's not necessary that in a consecutive order, if 3 sets and one set is not a subset of another set is not a subset of, then it's not necessary that the first set will not be the subset of third set. So hence we proved A is a subset of C. Next, question number 2's part 5th. If X belongs to A, X belongs to A is not a subset of B. Then X belongs to B. Okay. If A is not a subset of B, it means A's element doesn't consist in B set. So the statement is false, because any element of X cannot be in set B. With the help of one example, I will prove it. It is a false statement. Let's set A is equal to 1, 2. And set B is equal to 3, 4. So in this case, A is not a subset of B. X, it means X belongs to A, means 1, 2 belongs to 1 belongs to A, or 2 belongs to A. But 1 doesn't belong to B, or 2 doesn't belong to B. It means this statement is false. So none of the elements belong to another set, then that is not the subset. if A is a subset of B, A is a subset of B, X is not an element of B or X doesn't belong to B, then X doesn't belong to A. Yes, it is true. It's not necessary that a element of the superset belongs to its subset, but elements of the subset consist in element of its superset. So this statement is true. Let's solve it. A is a subset of B. A's element are 1, 2, 3. B's element are 1, 2, 3, 4, 5, 6. So here X belongs to 1, 2, 3 because 1, 2, 3 is in set also. So it is true that X doesn't belong to B if an element 4, 5, 6 are the 4, 5, 6 are in B, then these 4, 5, 6 are not in A. So this statement is true. So we have proved, and I have solved question number 1 and 2 of this exercise in this class. In the next class, we will solve more questions. Keep watching HomeLearns video. Thank you.